Hello and welcome to our second question on solving a problem through Simplex, on solving a linear problem through Simplex. Now I do understand the first lecture got a bit lengthy because we were exploring all the transitions between the tables, Simplex tables. Now the transition is very important because if we miss something out, then we might end up doing it wrong. So let us get on with our today's question. We'll take a small question and we'll see how those steps are very smooth. So let us have the question over here and then we'll talk about it. So the question says Z max is equal to 5x1 plus 3x2. So we need to maximize Z subject to 5x1 plus 3x2. We need to maximize Z, which is a summation of 5x1 and 3x2. So this time we are not formulating the problem is directly given because for formulation we can check out other videos. Today we will concentrate on Simplex. So Z max is equal to 5x1 plus 3x2 subject to certain constraints. Those constraints are 3x1 plus 5x2 is less than equal to 15, and then second constraint being 5x1 plus 2x2 is less than equal to 10. So it is a very small problem. We see that we have Z max, then we have two constraints. Now today we will see all those steps in sequence. It is suggested that if you could write down it on a piece of paper, then it will be better so that we could flow through it. You could pause the video, you could go on with your steps, you could tally your steps with the video, and we could proceed in this way. So let us get on with our question. So first step would be to convert all these inequalities into equalities. First step, starting point is convert the inequalities into equalities. The canonical form gets converted into standard form. How do we convert those inequalities into equalities? 3x1 plus 5x2. This is less than equal to 15. Now this side, left hand side is less, it is lighter. So how can I make it equal to 15? By putting something over here. So what I'll do is I'll add a slack plus S1, and when I add something, now it is no more less, rather it becomes equal. So this was conversion of first inequality into equality. Let us convert the second inequality into equality. 5x1 plus 2x2. Now this is also less than type. So I will add something. And this time I'll add S2. So both inequalities have been converted into equalities. Third step is, first step was converting inequalities into equalities. Second step is adding these slack variables, all the variables. Right now we are only using slack variables. In days to come we might be using slack variable, surplus variable, artificial variables, whatever variables we are using. These are decision variables. Then Z is our key variable. So all key variable, decision variable, slack variable, surplus variable, artificial variables, they all should be in my objective function. Objective function is Z max is equal to summation. Now right now, because we had only three variables, Z, x1 and x2, Z max, x1 and x2. So all three were in objective function. Now I have two more variables, I will include those also in objective function. If I have some more variables, I will include those also. How do we include them? I rewrite my objective function. Z max is equal to 5x1 plus, this is what we had in the question. Now my addition over here is S1, S2, and I multiply this S1 and S2 with 0. 0 into S1, 0 into S2. What this 0 into S1 does? It makes the term 0. This term becomes 0, this term becomes 0. So ultimately my objective function is still an accumulation of profits coming from x1 and x2. So it is still the same, but yes, these variables have been included in objective function to reflect all the variables available in one objective function. So first step was convert inequalities into equalities. Second step was include all the variables used in objective function. So today we'll put a small first sign over here. first step. Second step was including all the variables in objective function. From here on, we'll start solution of our question. How do we start solution of our question? First, we need to find out IBFS. IBFS is found out by putting all decision variables and surplus variables is equal to 0. Right now, we are not using surplus variables, but we are making use of decision variables. What are the decision variables over here? We have x1 and x2. So, IBFS is found out by putting all decision variables and surplus variables is equal to 0. So, in these two equations. So, if I put x1 is equal to 0, x2 is equal to 0, this equation becomes, this will be my IBFS. This equation becomes S1 is equal to 15, this equation becomes S2 is equal to 10. This is my IBFS. This is my starting point. If someone asks me, what is my IBFS, what is my solution right now, I'll say my S1 is equal to 15, my S2 is equal to 15, which means I'm not producing anything in first constraint, I'm not producing anything over here. All my availability of whatever material. In the previous question, it was machine hours. This could be availability of raw material, this could be availability of man hours, whatever the formulation suggests. All 15 is going unused, all 10 is going unused. This is my IBFS. And next, let us try and start the solution of this simplex problem. These are the two things. We'll put some color over here so that they appear to be different. Now let us start with our simplex calculation. So we'll push the question over here and then we'll start. Okay. Now simplex. So our first table would contain all these variables x1, x2, s1, s2, b and theta. Theta is the decision variable, decision parameter, which will help us in telling who is the outgoing variable. B is the quantity, B is the quantity, B is the answer, B is the value, B is the result at this stage. It could be quantity, it could be money, it could be protein, whatever. B is the result at this point. What is Cj? Contributions made by all these variables. Where are the contributions? In objective function. x1 5, 3, s1 is 0, s2 is 0. Then we have IBFS. IBFS is S1 is equal to 15, S2 is equal to 10. This becomes my IBFS where I am starting my question. Then these constraints need to be filled in over here. S1 is coming from first constraint. So what is the first constraint? 3x1 plus 5x2. 3x1 plus 5x2 plus 1s1 and there is no s2. So s1 is coming from first constraint, s1 is equal to 15. It is coming from first constraint, so this is the first constraint. The second constraint similarly would be 5, 2, 0 and 1. Then we write down contributions over here also. So s1 and s2. S1 contribution is 0, S2 contribution is 0. I'll put a 0 over here. Then we need to find out Zj. How do we find out Zj? Zj is sum product of the respective column and contribution. Respective column for first Zj, it will be first column multiplied by contribution. So 3 into 0 plus 5 into 0 5 into 0 plus 2 into 0. As we saw yesterday also in previous question, that in first table all these values turn up to be 0 only. And then we need to find out Cj minus Zj. This Cj minus Zj is known as net evaluation row. Why evaluation row? Because now I will be evaluating that what is the potential for growth. IBFS is this, but how can I improve upon it? This may not be the best solution, it is the basic solution. Now I am trying to optimize my solution. So what I will do is, I will find out this Cj minus Zj, 5 minus 0. Now if we remember, maximum profit potential is 5, maximum positive. These are zeros, they have 0 profit potential. This has a profit potential of 3 per unit. Every unit of x2 that is increased, it will give me a profit of 3. Every unit of x1 that is increased, it will give me a profit of 5. So 5 looks better, and this 5 gives me my key column. So this is my key column. Then we need key row. How do we find out key row? Theta is my decision parameter. How do we find out theta? Theta is nothing but B by A. This is B and respective column becomes A. So we get 15 upon 3, 5, 10 upon 5, 15 upon 3, 10 upon 5, giving me a 2. The least value gives me key row. Key column gives me incoming variable. Incoming variable. Who is the incoming variable? x1. Right now my solution is s1, s2. This is my solution. These are the values of that solution. So x1 is coming in my solution, either in place of s1 or s2. But key row tells me that x1 is coming in place of x2, because key row gives me outgoing variable. So this is the outgoing variable s2, x1 is the incoming variable. So now let us transfer this to our new matrix, new table. We have x1, x2, s1, s2, b and theta. Then we have our contributions as 5, 3, 0 and 0. So now x1 will be replacing s2. So I will be having x1 over here, s1 is still intact. S1 is not going anywhere, but this s2 has been replaced by x1. What are the contributions? S1 is contributing for nothing, x1 is contributing for 5. Now we can find out the remaining values. What are the remaining values? What is the rule for the remaining values? Here we have our rules. All elements divided by key element for key row. This is my key row. All elements should be divided by key element. All elements should be divided by key element. 5 divided by 5, 1. 2 divided by 5, 2 by 5. 0 divided by 5, 0. 1 divided by 5, 1 by 5, and 10 divided by 5, 2. So here we have transferred all elements of our key row. Now we need to transfer the remaining all other rows. The formula would be old row. Now we are transferring the first row. This was the key row, so we have transferred. Now we will be transferring the first row. Old row first minus key column element first. Old row first, we can write it down. Old row first, that is 3, 5, 1, 0 and 15. Old row first minus key column element first. Key column element first. This is the key column element. Key column element first, that is 3. Multiplied by modified key row. This was the original key row, this is the modified key row. So I get 1, 2 by 5, 0, 1 by 5 and 2, giving me 0. Then this would become a 25 minus 6, 19 by 5. This is a 1, this is a minus 3 by 5 and this is a 15 minus 6, that is a 9. So we get 0, 19 by 5, 1, 3 by 5, minus 3 by 5 and a 9. This becomes my second simplex table. Let me remove this. So I get my second simplex table. Now we have our Cj, we can have our Zj, and then finally we can have our Cj minus Zj, that is our net evaluation row. Zj, what is Zj? Zj is sum product of all respective columns, sum product of all columns with respective contributions. So all columns with respectively with contributions. 0 into 0 plus 5 into 1, 5. 0 into something. So all these will be 0 because this is 0. So all this is 0. This becomes 5 into 2 by 5. 5 into 2. This will become a 0. This will become a 1. So I have my Zj also. Cj minus Zj will give me net evaluation row. 5 minus 5 is 0. 3 minus 2 is 1, 0, minus 1. So, no potential, no potential. 0 means neither increasing nor decreasing. A negative potential means that the profit will actually come down. So, this is my selection, because this is the most positive, maximum profit potential. No profit potential, negative profit potential, and this is the best positive profit potential. So this gives me my key column, or in other words, incoming variable. Key column, x2 is my incoming variable, this is my key column. So I have my key column, I have my incoming variable. How do I decide upon where is x2 coming? X2 is coming in first row or second row. How do we decide? We decide by theta. What is theta? It is B by A. B by A is quantity upon A. Quantity upon A, that is key column. 9 upon 19 by 5. 9 upon 19 by 5, making it 9. Denominator gets flipped. So this becomes 45 by 19. And this would become a 2 divided by 2 by 5, making it 2. This gets flipped, 5 by 2. 2 cancels out, this is 5. This is 5. This is 5 and this is something 2 point something. So obviously this will be the smaller value. Smaller value gives me my key row, or in other words, outgoing variable. This is my key row, S1 is my outgoing variable. So x2 is coming in, but it is coming in place of x1. Now I know it. And this will be my key element. Where do I need key element? I need key element over here. When I transfer the key row, all elements are divided by this key element. So now I have everything prepared. Let me make my next matrix. We have x1, x2, s1, s2, b and theta with respective contributions of 5, 3, 0 and 0 contributions. Now s1 is being kicked out by x2. So I get an x2 over here, x1 is still sitting over there pretty well. Contribution of x2 is 3, contribution of x1 is 5. Now I need to transfer these rows over here. What are the rules for transferring? Key row is transferred after dividing all elements by key element. Key row will be transferred here after dividing all elements by key element. All elements will be divided by key element. 0 divided by anything would give you a 0. 19 by 5 divided by 19 by 5 would give me a 1. Divided by same thing. 1 divided by 19 by 5. 1 divided by 19 by 5 will give me a 1. This gets flipped 5 by, making it 5 by 19. 5 by 19. Then this one would be minus 3 by 5 divided by 19 by 5. Minus 3 by 5 divided by 19 by 5. Both denominators are 5. They get cancelled out. You are left with minus 3 by 19. Minus 3 by 19. And last one is 9 divided by 19 by 5. 9 divided by 19 by 5, making it 9. This getting flipped 5 by 19, making it 45 by 19. So I get 45 by 19. This was my transfer of key row. Now I need to transfer other rows. Which is the other row? Second one is the other row. What is the rule? Old row 2 minus key column element 2 multiplied by modified key row. Old row 2. This is my old row 2. 1, 2 by 5, 0, 1 by 5 and 2. This is my old row. Minus key column element 2. Key column element 2, because I am talking of second row, so I will take second element. This is 2 by 5. 2 by 5, 2 by 5. Multiplied by modified key row. Old row 2 minus key column element 2 multiplied by modified key row. Modified key row. This was the key row, this is the modified key row. I get a 0, 1, 5 by 19. Minus and minus will cancel each other to make plus 3 by 19. 45 by 19. If we try to solve it, this becomes 1, this becomes 0, this becomes minus 2 by 19, 95, 19, 19 and 6, 25 by 95. We could make it 5 by 19 and this would become a 95. 95 multiplied by 2 would make a 190. 190 minus 90 would be 100 upon 95. So making it 20 by 19. So we can have here 95, 19, 19 and 6, 25 by 95, if you simplify it, 5 by 19. And this one would become a 95, 95 multiplied by 2 would be a 190, 190 minus 90 would be a 100 upon 95, making it, simplifying if 20 by 19. So my transferred row would be 1, 0, minus 2 by 19, 5 by 19 and 20 by 19. So I have my first row, second row and third row. So this is my third row. Now can I find out Zj for it? Zj would be all columns multiplied respectively with their contributions. So 3 into 0, 0, 5. This would become a 3. This would become a 15 minus 10. 15 minus 10 would be a 5 by 19. This would become a minus 9 and 25. 25 minus 9 would be a 16 by 19. Now if I find out my net evaluation row that is Cj minus Zj. 5 minus 5 is 0, 3 minus 3 is 0, minus 5 by 19 and minus 16 by 19. So these two terms are negative, indicating that the profit will go down if I select S1 or S2. These two terms are 0, indicating that irrespective of what I do with X1 and X2, profit will remain there only. So now there is no variable which can improve upon my profit. So this is my iterative process from where starting from my IBFS, S1 is equal to 15, S2 is equal to 10. Starting with my IBFS, I try to optimize upon it in an iterative process. And finally, I reach a situation where none of the variables has the capacity to improve my profit. So my solution at this point, if I stop question and because it has been optimized, my solution would be x1 is equal to 20 by 19, x2 is equal to 45 by 19, giving me a z of, z was 5x1, 3x2, 5x1, 3x2, making it 100 upon 19 plus 135 upon 19, making it, this is maximum value of z that you can get given these constraints with this combination of decision variables. So this is my final solution, this is my final simplex table, which are stopped because I have all negative or 0 net evaluation, 0 elements in net evaluation row. And if someone talks of shadow prices, what will be the shadow prices for first constraint, second constraint? We can say that shadow price for first constraint would be 5 by 19, shadow price for second constraint would be 16 by 19. Thereby meaning that if I pump in more resources, if I pump in more units of, one more unit of first constraint, my profit will go up by 5 by 19. While if I reduce 1 unit of first constraint, my profit will go down by 5 by 19. If I increase 1 unit of second constraint, instead of 10, if you give me 11 units, if I increase 1 unit of second constraint, my profits will go up by 16 by 19. If you reduce it, my profits will come down by 16 by 19. So this was it for solving a linear problem using simplex method. Now the previous question was a lengthy one. Exactly, the question was not lengthy, but because we were learning the process, it got lengthy. Here we can see that the process is very smooth. All you need to remember is these two rules for moving from one table to another. And we continue up to a point where all these elements of net evaluation row become either 0 or negative. This is where we stop, because now none of the variables has a potential to increase my profit. So this was it for today's question. Now if there is something which remains unaddressed in this solution, then you can leave it in comment box and we'll try to work on those topics, those issues which we are not able to sort out over here. So thanks for watching. Bye bye. Take care.